Here are some solutions to perfect problem 2 for Math 243. The idea here is we're given some data. Looks like daily temperature and then how much coffee is sold. Okay. And we're asked to pretty much say everything that we've learned about this stuff. So the most important thing to do is first figure out what our explanatory variable is and what our response variable is. That is, which of these things causes the other one. I don't think you'd say that coffee causes the temperature to change, but you could argue that the temperature could cause coffee sales, as we could say this is the explanatory variable, which we usually use x's to represent, and this is the response over here, which we use y's to represent. And now that we got that out of the way, we can make a scatter plot. So let's see. Scatter plot on our x-axis, we want to have our explanatory variable, which is temperature in this case. See, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. That's probably good enough. Yours might be better looking than mine. And then coffee sales, what they go up to 40. So, I don't know, 10, 20, 30, 40. Good enough. And yeah, if you want, you could label these and be all pretty. This is temperature in Fahrenheit, presumably, because otherwise that'd be pretty damn hot. And here's coffee over here, whatever. And then what we want to do is plot all these points. So when the temperature is 30, they sold 36. So 10, 20, 30. 36 is somewhere up here. Temperature was 35. They sold 32. So 35 and 32. And you kind of continue in that fashion to put in all these data points. I think what I will do is pause this video and put in the rest of the dots so you don't have to watch me do it. Okay, so now I've made my scatter plot. Here's all my different data points. Looks like we have a negative correlation here. It kind of looks like a pretty strong correlation with the line going down. But we can figure that out if we go to stat, calc, and then linear regression on your calculator. It'll give you, after you put the data into some lists, make sure that, let's see, I guess I should be a little bit more specific. Linear regression, and then the list that your x variables are in, comma, the list that your y variables are in. So these guys, comma, these guys. What you get is a lot of information. It'll say something like y equals ax plus b, and a is equal to negative 0.434, 0.4, let's call it 0.43, good enough. And b is equal to 52.3-ish, if you round it off. And then r squared, they tell you is 0.85 about, and r is negative 0.92 about. All right, and with this information we can do a lot of stuff. Let's see, the first thing we can do is come up with our least squared regression line. We can say y hat, our predicted value of y, our predicted number of coffee sales, is equal to negative 0.43, whatever our x value is, plus 52.3. So what that is saying is that we have a slope and an intercept. The intercept tells you that if temperature were 0, maybe 0 degrees, we'd expect to sell 52.3 cups of coffee. Okay. And the slope over here is negative 0.43. And so what that tells you is for every 1 degree increase in temperature, we sell 0.43 less cups of coffee. Which kind of matches our intuition here. It looks like it's going down as temperature goes up. This tells you exactly how much it goes down. So let's see, what have I done so far? Scatter plot I have. Least squared regression line. I haven't graphed that yet, but I can do that. I have an intercept of 52.3. Okay, should probably extend this a little bit. Here's 50. So there's 52.3 up there. It's bad planning on my part. And the slope is negative 0.43. That is, our slope is negative 0.43, which you could think of as negative 43 over 100, if you want. And what that is saying is you should go down by 43 when you go over by 100. So rise over run. So we start at 52 point something. If we go down 43, or just below 10, and then you go down 100, you get another point over here. This isn't a data point. I should be careful there. It's just another dot that I can connect with a straight line, or at least I can attempt to make it a straight line. That was pretty damn good. And then this right here is my least square regression line. Alright, so I've made a scatter plot, I've made my least squared regression line, I've interpreted the slope and the intercept, mentioned an interpretation of my correlation coefficient R and my coefficient of determination R squared. So I got both of those over here. R tells me that I have a pretty strong because in absolute value this is close to 1. Negative correlation because this is a negative sign. And then this 0.85 over here tells me that 85% of the variance in my response variable in coffee sales is explained by temperature. So there you go. Got R squared, talked a little bit about them. And then it wants us to figure out the residual for the 14 sets, so for this observation right here. So which one? 14 and 92. So yeah, I guess this guy right there. Looks like it's right on the line, although it's probably not right on the line. We'll figure out where it is. So we can figure out residual is equal to observed minus expected. We can figure out expected by using our least squared regression line. So expected y when x is equal to, what was it in this observation? 92 degrees. What that would be, use the symbol y hat, and it's negative 0.43 times 92 plus 52.3. I cannot do that in my head, but I can put that into a calculator. Negative 0.43 times 92 plus 52.3. I got 12.74. So what we have is that our expected was 12.74. And then we can see, all right, how much did we actually sell? We actually sold 14. So we actually sold slightly more than expected. We get that our residual is equal to the difference between those numbers, a positive 1.26. And I'll interpret that by saying we sold 1.26 more because this is positive, cups of coffee than expected. So if you did this a little bit more carefully and maybe used a ruler, this purple dot would be slightly above this red line. But not bad considering I'm scratching this out on a computer. And I think that's the end of this perfect problem. Yours probably is a little bit different. You might write it up as a paragraph, but I think you got all the pertinent information on here, so hopefully that's enough for people to check it and kind of understand what they're doing.